Today we're going to go over the radical pre-assessment. We're going to have a group of radicals that we have to simplify. So the first radical we see is square root of 36. We should look at that and know that that is a perfect square. You could get into the habit of using the square root and go 36 square root, and that's going to work for the rational square roots, but we have to be careful about the irrational ones. But this isn't a bad, so we would just write 6. Square root of 16 is 4. Square root of 64 is 8. Square root of 196, so here's a great example. I don't know the square root of 196. I think it might be 13. 196 square root is 14. Hence why we do the work and check, or else you might be wrong. And here's a nice one. So I know that the square root of 144 is 12, and I have a coefficient of number 5. So negative 2 times 12 is negative 24. So remember, orders of operations tells me to do exponents before multiplication. So I have to do the square root of 144, which is 12, and then I multiply it by negative 2. We have 4 times 100, 4 times 10, which is 40. Negative 2 times 4, which is negative 8. And 196 again. 196, 14. So negative 6 times 14. I don't know what 6 times 14 is. 24 and 60 is 76. 6 times 14, 84. How did I get 76? 84, negative 84. 24 and 60 is 84. Said it right, you just didn't do the math right. That's why we use technology. All right, square root of 98. So I can throw in 98 and square root, and I get this irrational number. I do not want to see 9.899494936611665 on your piece of paper. That is not the correct answer. The correct answer is we have to find perfect squares within it. So the perfect square I'm going to test are 4, 9, 16, 25, 36, 49, 64, 81, and that's it. So I'm going to try those numbers, see if they're divisible into 98. So 98 divided by 4 does not go in cleanly. 98 divided by 9 doesn't go in cleanly. 98 divided by 16 doesn't go in cleanly. 98 divided by 25, I know it's not going to work. 36 doesn't go in. 98 divided by 49. 2. There we go. All right. So I'm going to break this into the square root of 49 times the square root of 2. Square root of 49 is a perfect square. Remember, these are perfect square factors. Factors of the number I'm dividing, 98, and the factors, specific factors that are perfect squares, because I'm going to simplify the square root of 49 to 7 rad 2. So that's why I'm always looking to break these, divide these by a perfect square factor. So 72, I know, square root of 9, square root of 8. Square root of 9 is 3 rad 8, but I have to make sure that this is simplified. So I can break rad 8 into rad 4 rad 2, and it becomes 3 times 2 times rad 2, or 6 rad 2. 24 is rad 4 rad 6, which is 2 rad 6. There are no perfect square factors in 6, so I can't break rad 6 down anymore. Ooh, 288. Yikes. That one's a weird one. 288. I'm going to first divide by 4, and I get 72. So I'm going to break this into rad 4, rad 72. That becomes 2 rad 72. Rad 72 I'm going to break down. I already know that rad 9, rad 8. So 2 times 3 rad 8. 6 rad 8. I'm going to break rad 8 to rad 4, rad 2. 6 times 2 times 2. Rad 2, excuse me. 12 rad 2 would be my answer. 216, another crazy one. 216 divided by 4 goes 54 times. So negative 3 rad 4, what did I say, 56? Oops, hard body. 216. 216 divided by 4. 54. Rad 54. Negative 3 times 2 times rad 54. Negative 6 rad 54. I know 9 goes into 54 6 times. So this becomes negative 6 times 3 rad 6. Negative 18 rad 6 would be my answer. 294. 294 divided by 4. Nope, doesn't go cleanly. 294 divided by 9. Doesn't go cleanly. 294 divided by 16. Should not work. 294 divided by 25 is not going to work. How about 36? I don't think that works. No. 294 divided by 49. 49 and 6. 49 and 6. So, and 6 times 7 rad 6, and we get 42 rad 6. That's a good one. 75, so that's a negative 1 outside there, times rad 25 rad 3. Negative 1 times 5 rad 3, or negative 5 rad 3. 50, negative 8 times rad 25 rad 2. Negative 8 times 5 rad 2. Negative 40 rad 2. Well, here's our first variable, so we're going to keep our constant, and we're going to separate it from the radical with the variable. Rad 16 is 4. Rad x to the fourth gives me x squared. Remember, I can divide that by 2. I'm going to separate these. Rad 64, rad r to the fourth. 64 is 8. Square root of r to the fourth is r to the second. Now I'm going to separate these. Rad 45 is going to be broken into rad 9, rad 5. Rad v cannot be simplified, so that's 3 times rad 5, rad v. We're going to have to put those together and get 3 rad 5v. So at the end, we want to put all the things outside together and all the things inside together. Square root of 64 rad x, that's going to be 8 rad x. Rad x cannot be simplified, much like rad v cannot be simplified. Now we have a coefficient here, so I'm still going to separate them, which is rad 9, rad 2, and I'm going to break that to, I'm going to just do that. We could do divide by 2, and you get 1 outside with 1 left over inside, but I'm just going to show the work. And now outside we have 8 times 3 times x, which is 24x. And then we have rad 2 and rad x on the inside. So we put those together. So we get 24x rad 2x. That's a good one. 7 times rad 18 rad b. 7 times rad 9 rad 2 rad b. 7 times 3 rad 2 rad b, and you get 21 rad 2b. Negative 5 times the square root of 100 times the square root of v. Negative 5 times 10 rad v. Negative 50 rad v. And last but not least, 2 times the square root of 112 times the square root of r to the 4th. So you get 112, I think 4 goes into it. Divided by 4 gives me 28. So rad 4, rad 28, and that's going to give me r squared. So let's 2 times rad 28 times r squared. So that's 4r squared rad 28. Rad 28, can we simplify that? Is there a perfect square factor inside of 28? Yes, there is. So that's going to give me 8r squared rad 7. I think that's it. Yep, good. All right. Come and see me if you have questions before the assessment.